So in today's lecture, I'm going to calculate the reliability of a really complex system. And there are two types of systems that I'm talking about. One is series reliability, and we're going to be talking about that in the future, and parallel reliability. And we're going to do a combined exam of the two together to calculate the overall system reliability. What's going on and started. So IK mentioned one of the major activities within both quality and reliability engineering is understanding that the total reliability of a system for a very large group of people is complex as a product or complex, which I mentioned in the first slide, the reliability of automobile. It's a powertrain. You have to think about the combination of all the individual reliabilities and associate them with the components of the substance abuse system, which make this process, like I mentioned before, Capuchin, which is a category of type of system, which is in compilatory regulation with a linear series. And the next is a parallel series with today. Okay, so let's start with series NBC, and I think the power training, the automobile, and taking it in the series system, which I want to calculate as an overall reliability of these subsystems. In series, for example, the powertrain has an engine and a transmission and a transdraft, which is getting all the wheels and components from series, which is a whole system for successfully operating each individual component, which has to rely on one on the other. So this is how you calculate a series of system reliability, and seeing the equations right here and the subsystem reliance. So it's simply equal to the reliability of the mods with the tattoo and relying on the subsystem 3 and on. So I do an example, and I assume that even if the model of the comes by sea, in 100 or 1,000 miles, each of these components has an individual reliability of many percent. And the question is, what is the overall system? Is it where each of the components has a reliability menu set? We have to update the block and do the reliably with each particular subsystem. And now we can plug those numbers in and we can pick it. And all of this is based on the reliability of the powertrain. Not simply adjust. We need to represent and we need to send and all the way down to the final accumulative reliability SAM, which is 70, 80%. One more example. Our components are different models of reliability, so you can see how they affect the equation. And let's say we're talking about the dishwasher, okay? So I like talking about the home appliances because these are the things which whoa, hello, so cheap, reliability. And they're capable over a period of time, of course, defined as credit, debit, dishwasher, reliability. So again, there's that equation for a series system, and again, for your dishwasher to work properly, and to go through all of the phases, filling in the washing, draining, drying, everything that the dishwasher does, you need to dance with the dishwasher in a valve. So it comes to pump, motor, and all of these different elements, the subsystems within the dishwasher. It all happens to be working in a linear fashion with the entire dishwasher. So if any of these systems stop working, the dishwasher is going to work properly. And that's why they're in series with each other. And what we can do is we can override the reliability method. And we know that this reliance on these individual components that are 1,000 cycles, 900 cycles, valves, and all these reliable systems, electrical controls, and all these sublevels of pump, we can rely on them to measure the reliability in cycles. So the overall system of relay is relaying the reliability. And so here we can simply plug these liabilities into that equation, and 90%, 75, you can always come back to the pulling in the individual reliability down from the certain components of the equation to come up with an overall system of reliability at about 80%. And you can interpret that value in two ways: as a dishwasher at home or a business with the cycles, like 80% chance that the light dishwasher is going to crackle. You can interpret this as a big picture and organization. I don't know, a million dishwashers stealing the operation after 1,000 cycles. 1,000. Let's move to the parallel reliability with a parallel system where we really need reliability and a Mr. High. So we often design this with products that are pack wrap. These subsystems on this are entire systems impacted. So I want to help you graphically visualize this to understand this idea and parallel system. So the way this is constructed, let's say we have 4 subsystems, A, B, C, and D, and they're identical in their subsystems. They're all mustering with the entire system reliability impact. So this is redundant, basically standby system. And the way I can calculate this reliability of a parallel system is I take 1 minus the unreliability multiplied together. What is it? It's a new term for the unreliability measure. 1 minus it.